to talk about a particular programming pattern that you're supposed to learn from the tutorial video. It's quite a challenging one, combining array for the attributes. Let me just go over together with you with the basic pattern just to review, and then we'll do one challenging accessor method built on top. Okay, it's on the slides, but let's do it together. Basically, we talk about Java data types. Especially, you can declare your attributes of type an array of some reference type. Okay, let's have a quick look to see how it looks like. Okay, let's say we have a class called PointCollector. Okay, by the way, if you go to slide number 54 on your slides, and then you will see that there's a document over here which I also refer you to for lab number 6. That's a required reading for you to do. Okay, which will summarize the programming pattern that you're supposed to learn. Okay, let's now have a look at the code together, and then we'll trace it together just to review the pattern. Okay, so now if you look at this class here, PointCollector, so the name suggests we're going to collect point objects in this particular class. That means every instance, every object of type PointCollector is going to have an array of points. How does that, how can that work? Line number 2 is really critical. Oh, actually I got 2 attributes over here. I just put them into one line just to save the space. So these are the 2 kinds of attributes you want to get used to for this particular pattern. Because for your lab test number 3 next week, you are not allowed to use any Java library classes. So you have to use primitive array. And this will be the pattern I suggest you use in the lab test. Okay, let's have a look exactly what was declared over here. Let's go to the iPad over here. Okay, I'll show you. So now, if you, let's go over the code structure very quickly. That's exactly the same pattern as you pick up from the tutorial video for this week. Number 1, we declare a variable called points over here. Okay, it's called points. And then what's its type? The type is simply an array of point. As we talked about before, if you declare an array variable, the type over here means every element in the array is going to store the address of some point objects, right, as we talked about. So that means at the runtime, every instance of type PointCollector is going to have an attribute that stores an array of point object references. Okay, that's what's going to happen at runtime. And the second attribute we're going to have is called number of points. It's just a counter. Basically, it's going to have 2 purposes. Number 1, it's going to tell us how many points you have stored so far in the collector. By default, it's just going to be 0. Nothing has been stored so far. And then number 2 is going to tell us if you want to store new points to the collector, this is where you should store that into. Okay, so these are the 2 purposes I reviewed already in the tutorial. But let's just have a look at it one more time. We'll go in there in just one moment. And also, we have the constructor over here. You can see that here. So this is a PointCollector constructor over here, which takes no input. But what should we do over there? Typically, there are 2 things you have to do. Number 1, you have to initialize the points attributes. Number 2, you have to initialize the NOP, number of points attributes. So these are the 2. So now, as you can see, I'm doing here. So points over here is the array. It is simply assigned to a new array of size 100. So whenever you're solving a problem using this pattern here, you will be told what should be the maximum number of objects you can store into the array. In this case, let's assume that's simply 100. I think in the lab tutorial you got 50 or something, I forgot. Okay, so you will be always given a maximum number of objects you can store. You will always be given, so you don't have to worry. So now what we have is when we first create the PointCollector objects, we're going to initialize the points array to be of size 100. Okay? And then, in this case, what should be the value for NOP? It should be 0 to begin with, because in the beginning, you have not stored any points so far, so 0 points you have stored so far. And then also, if you want to store the next point, it should be stored at index 0. Okay? So default value should be just NOP. And this is exactly the default value for integer. So remember, if you do not explicitly initialize a primitive attribute like an integer, you will keep the default value. Okay, so we don't have to do anything here. But if you want, you can still do this.NOP is assigned to 0. You can also do that. That's not a problem. Okay? And then we also have this line, block of code over here to add points. Here, I'm only showing you one version over here. In the tutorial video, I show you two possible versions, okay? This version here, when I want to add a point into the collector, I'm simply giving you the information that will be necessary for you to create a point objects, okay? So what do I need to create a point objects? I need the x and y coordinates value, two doubles, okay? So these are the two things. So what do I do over here? Again, there are two things you got to do. Number one, because we know that the current value for NOP tells us where in the collector to store into this particular points. So I would say points at position NOP is assigned to a new object over here. In this case, I'm simply using x and y, the parameters, to create the objects. And once I create the objects, store the address of that object into the correct position. Okay, I'm just going through quickly, and then we'll trace the code together. After that, you have to make sure you update the NOP by just 1. So NOP is a counter that will simply just increment by 1 every time you want to add a new point, okay? So now let's trace the code all together, okay? So what I will do is I'm going to clear the code fragment over here, and then we'll do from scratch, okay? It's really important for you to see this pattern here. You're almost likely to use it in the lab test 3. So now let's focus on the tester, and then we'll trace line by line. And then we'll visualize what's happening here. Okay, so now we talk about the PointCollector tester class over here. And then we also got a main method, so we should see some console output. So now, first of all, first line. First line, let's put that into green over here. The first line, so what are we doing here? We're simply creating a new object, PC, of type PointCollector, which means PC is going to store the address of an object of type PointCollector, right? And how many attributes do we have for PointCollector? As we declare, it should have points, which is an array, and also NOP, which is an integer. So these are the only two attributes. And initially, we are simply going to call this line over here to initialize the array, okay? So now, let me just show you exactly how it will look like. So now, I'm going to draw a box over here, which tells us that's an object of type PointCollector. Okay, I'm going to write it down. PointCollector over here. And then we got two attributes over here, NOP and points. Let me put NOP at the top, okay? NOP over here, and we know that by default, since we do not try to initialize it explicitly, it will keep the default value 0. So it will simply just be 0, okay? And then we also got this array called points, right? I'll put points over here. And now, how do we initialize the points array? As you can see, we simply say initially, when you call the constructor, points will just be an array of size 100. Okay, let's do it. So that's going to be pointing to some array of size 100. As we learned very well, if you got an array of size 100, indices should be from 0 until 99 inclusive, right? So let me just do a few over here. Let's say 0, 1. Eventually, we want to add 1, 2, 3, or 4 points. So 2 and 3, dot, dot, dot. It goes on until 99. Okay, that's kind of the pattern. But for now, for this particular case, we're just going to add 4 points into it. Let's see exactly what's going to happen. So once you create this object, PC is going to point to it. In this case, we are only showing one point collector. At the runtime, you can create as many point collectors as you like. So now, let's see exactly what's going to happen here. Okay? So now, let's trace the very first one very carefully. Let me use pink for the first one. This one here. When we say PC.add points, oh, sorry, before I do that, can we just have a look at the console output quickly? What's going to happen if we try to print out this particular line here? When I say system.out.println PC.NOP, basically before I try to add any points, what should be the value for NOP? As you can see, PC is now the context object over here. Let me show you. PC is the context object dot, which means I'm going to follow PC and go to the object that's being pointed to, which is over here, and then .NOP, which will be the value over here. In this case, it will simply just be 0. That's easy. That's just in the beginning, before we add any points. So now let's try to add a very first point over here. When I say PC.add points 3, 4, okay? we got something very similar in the next few lines. Okay, let's trace the very first one very carefully. Well, maybe the first a couple of them. So now, again, you can see that always focus on what the context object is, so you know which one to change. Context object now is PC. Let me use pink. PC is now the context object over here, which means we are trying to modify whatever object that's being pointed to by PC, which is this object here, right? Let's first of all clarify that. And then we got arguments 3 and 4, and we're trying to call this particular addPoints method, okay? Let's talk about the context object first. We know that we're going to execute this particular method for the first time, addPoints. And we know that because PC is actually the context objects. So that means every occurrence of this is going to be replaced by PC, right? Now, notice one thing here. Every time when you're given the code, you are not necessarily always given the version where you can see the this. So you should really know yourself how to really put the this back. This keyword, as we explained, is only implicit, okay? So now, let's have a look at this. If you look at this particular block of code, addPoints over here, when you say points over here, it's as if you say this.points. Okay, I'm just trying to add up just by myself. Because when you're given the code, you don't necessarily get a this keyword always. You should know where to add it. Similarly, when we have x and y over here, x and y is referring to x and y in the parameter, so you don't have to add this. It wouldn't be right. Okay, so these two are okay. And what about NOP over here? NOP here is referring to indeed the NOP attribute over here. So implicitly, you also got this. Okay, I can also say this dot NOP. So these are the two occurrences of the implicit this I just added. Okay, just make sure you can add it as well by yourself. Okay, let's go back to this particular method call, because we know that PC is the context objects. Every occurrence of this is going to be replaced by PC. So now this is going to be replaced by PC, and this also is replaced by PC. That's what we have, right? And also similarly, you can see the arguments over here is 3 and 4. That means every occurrence of x is going to be replaced by 3, right? So here is also 3. And also every occurrence of y is going to be replaced by 4. So now we have enough information to know exactly what to be done. Let me write it down precisely what you should do, okay, for the first time. So let me write it to the right, the pink one. We are trying to do PC.points at position NOP over here, of course, it also has an implicit this. Okay, I just put it down here. PC.NOP as well. Okay, it's assigned to a new point objects where we got 3 and 4 over here. Okay, that's the first line. And then the second line we have to execute will be PC over here. You can see PC here, PC.NOP plus plus. Okay, let's do this very carefully for the first time. And starting from the second time, it will just be the same. Okay? So now let's see how 1 is going to be executed. 1. When we say PC.points, which refers PC.points, is referring to this particular array. And we say go to this particular index, which is PC.NOP. PC.NOP is currently just 0. So we go to index 0. Okay? So far so good. That's the left-hand side of the assignments. What about the right-hand side? The right-hand side is just a new expression, which means we are creating an object of type points, just a new one. Let's create an object first. So the right-hand side, I'm going to use orange to show you. Okay? The right-hand side over here is going to be a new point object. I'm going to put it over here. Okay, let me just put it here. What we're going to have is, we have the point objects over here. Every point has x and y, as we assume. And also you got 3 and 4. So that means x will be 3 and y will be 4. So now, what's really important is this particular equal sign for the assignment over here. So what does that really mean? That means we want to store the address of this particular new object over here into index 0 of this array. That's what we want to do. Okay? So now, once you store the address into this particular index, it's as if you're trying to point to the objects, right? As we said before. So So now what we're going to draw is, I'm just going to draw like this. Okay, that's what's going to happen after adding the first point. Okay, you shouldn't be too surprised because that's exactly what's taught in the tutorial video. Okay, please review that. So now after this is only about the first line. What about the second line? The second line is very crucial because we want to make sure next time if you want to add a new point, let's say a second point, you should really store that maybe in index 1, for example, just store from left to right. You want to make sure NOP is properly updated. In this case, you will simply say NOP plus plus just by adding 1. So now it's going to be updated from 0 to 1. So this is exactly the state after you try to execute add point for the first time. But now we're going to execute it for 3 more times. Okay? Without going through the code again, which you can follow through exactly what I just said, but let's see exactly what's going to happen. I'm going to draw it to you to show you the process. It's really important. Okay? So now let's look at the second line over there. So by the way, after this, when we say system.out.println and then pc.nop, right? So what should be the NOP right now? It should be 1, right? Because we have just added 1 point. Okay, so now there should be no trouble here. So there should be just 1, not a problem. So now let's try to add another one into the points. If I call pc.add points, and then I would say -3 and 4. It's basically the same structure over here, except that we are just adding a new point with x and y being different, right? Let's try to draw that very quickly, conceptually. Conceptually, what's going to happen is we're going to create a new point over here. Okay, just a new points, just another objects. And we're going to have -3 and 4. Okay, so now you got x and y being -3 and 4. Okay, how do we add it? This time it's going to be already here. PC dot points at position the current value for PC.nop. PC.nop over here is assigned to basically this particular point, right? It's going to be assigned to this particular new point object. I'm just sketching the idea for you. So now what's the current value for NOP? It's been incremented to 1 from the previous call, right? So that means we are trying to update this particular slot of the array instead. And then it's going to store exactly this particular address that we just created. So now it's going to point like this. Okay, so now the second index, which is index 1 of the PC.point, is now pointing to this new blue point object over here. And don't forget, after that, we also have to say PC.nop plus plus to make sure the next time, if you want to add a third point, you'll add to the right position. So after this, we're going to increment from 1 to 2. Okay, so this is the stakes after we have added 2 points. Yes? NOP, by the way, is an integer. It's not an array. Yeah. For NOP, okay, you want to talk about initial value for NOP, right? Okay. Basically, okay, the version I'm presenting right now in the slides is slightly different from the one I presented in the tutorial, but they're equivalents. Let me just emphasize it again. Let me show you in a new page. If you look at, let's say this, in the slides, this, okay, let me just go a little bit downwards. In the slides, okay, so we talk about class PointCollector. This is what you will see. Okay, we got integer NOP and attributes, and also we got point, and also let's just say PS for points. And then this is what I declare. PointCollector. Okay, over here I only got a single line. I say this dot points PS is simply assigned to a new array. Let's assume we have no more than 100 points. Let's assume that's a version we just see. Let me just let me write very quickly the one you see in the tutorial video, and then I will tell you why they are equivalents. In the tutorial videos, you got something very similar. Let me just repeat very quickly. Okay, you got something also maybe called PointCollector. I think in your tutorial video it's called students rather than PointCollector, but the same idea. Okay. Okay, you also got the class over here. Also, we got integer, NOP, and also you got points. Also, let's say PS. I'll just make it the same, so it's easy to compare. And also, we got PointCollector over here, the constructor. But now, over there, I'm going to have 2 lines rather than 1 line. I would say this dot PS, the same as before, new point array of size 100. And then I'm going to say this dot NOP is assigned to 0. Okay, so really see the difference over here. So now in the tutorial version, I explicitly initialize the NOP to be 0. For the reason that initially there's no points being added, it should be 0. And also for the very first point to be added, it should be at index 0, right? For these 2 reasons, that should be 0. However, why are these 2 versions just the same? So these 2 versions, they are simply the same. It is because if you look at this particular constructor over here, you can see that attributes NOP is not initialized. And we said before, if the attribute is not initialized explicitly, it will keep the default values. In this case, it is of type integer, so it will keep the default value 0, so they're equivalents. Okay? Yeah. Now initialize, they will simply just get default. Sorry, let me write it properly. Default value will simply give you 0. Okay, they're equivalents. So now you want to be very careful. If somehow mistakenly, let's say this. Let me give you one example here. If mistakenly I say this NOP is simply assigned to 1 rather than 0, what's going to happen here? I can tell you that it's wrong. But you want to visualize why it is wrong. Okay, let me mention that quickly. So this is the kind of variance you want to really apply to yourself when you review the tutorial video for the exam. I might just tweak the program a little bit to actually test your understanding. Let's say this, for example. Rather than initializing the NOP to be 0, I simply initialize it to be 1, let's say. What's going to happen is like this. I still have the PointCollector over here, which will point to some point, I'll say PC for PointCollector. And then I have initially NOP being 1, okay? And then also I got this particular PS array. It is pointing to an array of size 100, right? 0, 1, and say 2, all the way to 99. Okay, and now currently all the slots in the array stored none to begin with. So now let's see this. If I try to say PC, after this I say PC dot add points. And then let me simply say 3 and 4. Now what's going to happen? If you simply try to execute the same block of code over here, I just wouldn't repeat the code, right? You can see it on the slides. If I simply say PC dot add points 3 and 4, what's going to happen is we're going to create a points object over here in the blue, and then we got X and Y, 3 and 4. But now, where exactly do we store the address of this new point objects? 1, okay? So that means position 1 is going to store, because you can see it should be exactly the NOP value, right? So that means we're going to store from here rather than the leftmost. So that's where the logical error is. So that means you're wasting 1 slot from the array. Yes? Okay, that's a very good question. At the moment, over here, if you simply do this, let's say after this, if you simply say PC.PS at position 0, presumably that should be a point object, right? If you simply say move up by 3 units, for example, in this case, yes, you're going to have null pointer exception in this case, right? Because over here you can see that PC.PS at position 0 is referring to this particular slot, which was ignored. In that case, you're going to get null pointer exception, yes. On the other hand, if you say something like this, if you say PC.PS at position 1 dot move up by 3. In this case, you want to read this diagram. PC.PS at position 1 is referring to this particular slot. It does refer to a valid point object. In this case, it is okay. You just move up by whatever units it is. Okay? It's just a long response to your question, but you gotta be careful with the NOP value. Okay. I do have a question for you. Okay. Let me give you something you can also try to think about. Let me just write it down very quickly. Okay. Let's say we have the same point collector over here, the same. And then I still have integer NOP, and also I have the point array over here, and also let's call it PS. Now let me do a little trick to the constructor. I simply say point collector over here. I leave it empty, nothing there, okay? And then I still have my void add points. Okay, of course you might have something over here, and then you do exactly what's the same as before. The only thing I changed was over here is simply just empty. It does nothing. Conceptually, that simply means when I first create a point collector objects, I do not intend to initialize the array for points specifically. So what would be the default value for the points array in this case? Remember, array is simply storing to the beginning address for the element, right? Then in that case, it would just be null. Okay? So now, let me show you exactly what's going to happen here. So now, let's say you define something like that. Now, let's say in the tester, you simply say point collector PC is assigned to new point collector. So far, so good. So what's going to happen over here? Basically, we're going to have control here. You will say PC is now pointing to a point collector array. Oh, sorry, point collector objects, PC, I'll say here. And then NOP, and also PS, the array. And, excuse me, over here, the point collector over here is simply just keep the default value for the integer. So that would just be 0. And also, nothing is going to initialize the PS over here. And we know that PS is of type array. Array is a reference type. In the beginning, it's simply just going to store null. Okay? Keeping that in mind. If I say now PC dot add points, and then I'll say 3 and 4. Will I be able to add this new point into the collector? Or am I going to run into some trouble at the runtime? Well, think about what's going to happen. Let me add a little more details over here, right? We know that it should be this, the PS at position NOP is simply assigned to the new points, right? The new points over here, X and Y, right? Because we got X and Y over here. And also after that, you would say this dot NOP plus plus. Let's think about this. For this particular call, PC is the context object. So now we know that this should be PC, right? And NOP over here should be PC.NOP. In this case, that should be 0. So we are really talking about PC.PS at position 0. Agree? Now, are we going to run into trouble if we try to evaluate this expression over here? That's the question. The answer is yes, but what kind of trouble are we going to run into if you look at that? If you look at that over here, let's try to analyze this expression one by one. When I say PC over here, PC is really referring to this particular address over here. When I say PC dot, it's referring to this particular point collector object over here. So far, there's no trouble. And then we say PC.PS. PS is referring to this particular array object over here. At the moment, so PC.PS at the moment is simply just going to give you null. Right? And now when you say PC.PS at index 0, this is the part where you're going to run into trouble. Because we know that PC.PS is simply just null. So basically you're saying null at position 0 conceptually. It's simply not going to work. Because the array has not been stored anywhere. It's simply, at the moment, simply null. So when you say the array storing nowhere, well, you want to find out where index 0 is. Of course, it's going to run into null pointer exception. Okay, so this is null pointer exception. Okay, so that's not going to be good. To make a quick recap for this slide here, basically what I'm trying to do is I simply say you want to be very careful with the constructor for the collector over here. You want to make sure, number one, the array is properly initialized to be a certain size. Number two, you want to make sure NOP is of value 0 to begin with, right? But now I'm omitting 2, both of them. That's kind of the trouble you'll run into at the runtime. Give it a try on Eclipse and make sure you can reproduce it and understand what's going on here. So that can be also a potential question I would like to ask you about. Okay? So once you understand the tutorial video, I think the most important thing is to see exactly how this programming pattern is supposed to work. The programming pattern itself does not contain many lines of code, but you don't want to memorize it. It's not going to help, right? You really want to see the logic behind that. So if I only change just 1 line or 2 lines of the implementation, the behavior will be different. So you don't want to really just memorize. That won't help you too much. Okay, let me go back here. This original place over here. So after that, after we have added 2 points over here, if we try to print out NOP, it's just going to be 2. Okay, so let me just finish the diagram quickly just for completeness. And then I want to talk briefly about static variables, which is actually part of your practice test for lab test 3. Okay, I'll talk hopefully at least some part of it and finish it on Wednesday. So now if I try to execute 2 more over here, 2 more of the adding points. I want to say pc.addPoint -3 -4. What's going to happen? What's going to happen is, now without telling you exactly how the code is going to be executed, let's draw it quickly. -3 -4. I'm going to create a new object over here of type points. With x and y, it's now going to be 3 and -4. 3 and -4. Okay, so now the current value for NOP is 2. That means if I want to add this new point into the array, it's going to be at index 2, right? So that means index 2 is now going to point to this object over here. At the same time, I'm going to increment the NOP for the next one. So it's going to be incremented from 2 to 3. Okay? That's what's happening after the 3rd point addition. So that's why when you say system.out.println, pc.nop is going to be 3, right? That's your final one, okay? Just for completeness. For the final one over here, let's say use red. I want to say pc.addPoints and then 3 and -4. Okay, that means we're going to create another point object over here. If every time you see the new keyword, just draw a new box on your paper. Okay, you got a point over here, and then you got x and y. Now 3 and -4. So I got 3 and -4. Okay, so now the current value for NOP is 3. Okay, it's basically 3 over here. So I'm going to store the new points, its address at position 3 over here, and then let it point to over here. After that, I'm going to increment the value by 1. It's going to be 4. So now you really get some intuition about how things work visually. Okay, it's easier for you to understand. Programmatically, you just want to know when I make a method call, what's going to be the consequence of making the method call. Hey, any question about this pattern over here? Yes, the NOP is always 0 because it's integer, right? Default value. Okay, I think up to now, you're familiar with the programming pattern already. So for that, you should be ready for lab test 3, just for this part. I will leave the complicated one, the accessor, which is to get. This is a little bit more complicated. I will save that for Wednesday. Okay? On Wednesday, we're going to talk about, if you look at the slides, so we can define an accessor method to say once you have collected certain points, I want to only find out those points in a particular quadrant. Okay, that's something I will talk about maybe on Wednesday quickly. Okay, but let's for now talk about something called static variables. Okay, what I want to really show you is on the Eclipse, so we can do it all together. So now I already got 2 classes created. I have one class called counter. I have another class called counter tester. Okay, I want to show you exactly static versus non-static. Let me give you some intuition page right away, so you will understand something in here. Okay. Basically, so far we talk about, let's say if you say integer, let me show you the context. If I have some class, I would say C, any class, okay? And I'm trying to declare attributes inside this class. I have, let's say, I can say either integer I, okay? And as we learned before, I is simply going to be available for each instance of this particular class C, right? Okay. Now, let's introduce a new keyword to you called static. I'll write it down. S-T-A-T-I-C, static. And then I just put I over here, integer, and I. So you can see the only, not just I, you gotta be a different name, J. Okay, let's clarify the terminology very quickly. In this case over here, you do have a static with a J. You will say J is a static variable. That's easy to see. What about I over here? I, when you declare it, does not have any static associated with it. It's called non-static. Just simply not static. Most of the time, most of the variables you have for your class should be non-static, most of the time. How can a static variable be useful? Let me just give you a quick summary quickly, okay? When you talk about non-static variable, that simply means each object or instance has its own copy of I. Let's say this, if you got two objects of type C, let's say you got C1 and C2, right? If I say C1.I versus C2.I, we know very well they refer to different copies of the I variable, right? C1 versus C2, because the context objects are different. Okay, that's easy. What about when we have static over here? Whenever you got static, that means the variable over there is somehow global. Global in the sense that every object share the same copy. Okay, I'll write it down here. And over here, it simply means when you got static variable over here, you can say all objects or instances share a single copy or global copy of J. Okay, so whenever you're trying to change the value of J, it's going to be changed. Let's say this. If I say C1.J versus C2.J, over here I'm referring to the J over here. The two J's are referring to the same copy of the variable. If you change one, it's going to affect the other. Okay, it's a very quick summary over here. But let's now have a quick look on Eclipse very quickly for you. Okay, we've got about maybe 10 minutes or so. Let me show you quickly the syntax difference and also how they behave differently. So now in the counter class, I'm just going to create two attributes over here. Okay, let me cheat a little bit. So now I'm going to declare two attributes over here for you. I'm going to have one, I would say integer L. L stands for local. Okay, so this is a non-static variable attributes. How about that? Okay, because we declare under the context of some class, so let's call it attributes. Now I'm going to use the keyword. I'm going to say static integer G. Okay, this is something you may want to use to solve the practice test problem, where you want to solve the membership ID. Okay, I will show you the exact solution on Wednesday, but today I just want to show you how static works versus non-static. Over here, I would say, typically, as I said in the tutorial video, we only try to initialize attribute values in the constructor. For the static variable, because they're global, you may want to initialize right away. Okay, so that's the difference. Integer G is 0. Okay, so I would say this is a static attributes. Okay, that's it. And now I'm going to just define constructor quickly. I can say counter, and then I would say L. Okay, this dot L, the local, is simply assigned to just 0. Okay, this is where I initialize the non-static attributes. For the static one, I already initialized it to be 0. Okay, after that, I'm going to define two mutator methods quickly. One would be, if I can say void increments local. Increment simply takes no parameter just because it's easy. You just increment by just one. Okay, I can say this dot L plus plus. Okay, I'm just updating this particular non-static attributes over here. That's easy one. Let's see the second one over here. I would say void increments global. So global over here, and then I would say G plus plus. Okay, I kind of omit this over here. Okay, let's see. What if I put this? One thing you should note, G over here was declared to be static. Static in the sense that every instance of type counter is going to share a global single copy of the G variable over here. And now, when I say this over here, there was not an error. You can see there's no red cross. It simply, instead, it's like a yellow warning. I'll read it to you. Okay, if I move your mouse over, it says the static field counter should be accessed in a static way. So what does it really mean to really access it in a static way? I'll show you. Okay, you have seen how to use static variables so far in one particular instance by using a math class. Okay, but let's not worry. We'll do it together. Okay, just for now. Okay, so now we just say this gives you a warning. Okay, so what you can do instead would be the G++. There'll be no warning. Okay, any question about what we have got so far? Basically, we have two attributes. Line number 8 is a non-static attribute. Line number 9 is a static attributes. Okay, what we're going to illustrate is the attributes L is going to be local, and the attribute G is going to be global. So what do I mean by that? Okay, let's do some experiment here. So now let's go to the counter tester over here. I will do some tests together with you, and then I'll visualize it. So what I will do now is, first of all, let's create two counter objects. I can say counter C1 is new counter over here. Okay, and then I'm going to have another one, counter C2. Okay, two counters. Let's try to visualize exactly what's going to happen right away. Okay, let me just start a new page on iPad and then we'll switch. Okay, so far we got C1 and C2. They are two objects, right? So now let me move the iPad here. What we have is like this. So we have basically C1 is pointing to a counter objects. I will talk about the contents of the rectangle box in just one moment. Okay. Also, C2 is also pointing to a counter objects over here. Okay. Now, how many attributes should we draw in the box? If you look at that, the eclipse over here, you can see each counter seems to have two attributes over here, right? But that you're not going to draw two. Whatever attribute we talked about before, we always refer to non-static attributes. But now, since we introduced static, you want to draw it a little bit differently. Okay? So now, inside every instance of object box, you only include non-static attributes. Okay, you only do that. For the static attribute, you really put it aside. That's going to be maintained separately. Okay? So what we're going to do is, we're going to draw like this. So we got local L, and also we got local L. Right? Local. What about the static variable G? We're going to put it aside. Okay? I'm just going to do it like this. It's not really an object, but just like a global variable over here. So I will still put counter over here. Okay? That means that all the global variables for counter class. Okay? And then, let me put G over here. Okay, G over here is global and also shared by all counter objects. One thing you can see right away. How many copies of the local? Two copies. One for each object. How many copies do we have for the global? Just one. Okay? You always have just one copy of the static variable, always just one. That's why it's called global. Okay? Once you get this mental picture clarified, what's going to happen should not be too surprising to you. Okay? Basically, what I'm going to illustrate is like this. whenever I change, for example, if I want to make a change to this particular local copy over here, it should be it should not affect this copy over here, right? They're separate copies. On the other hand, if I change the value of the global copy over here, it should be visible to both C1 and C2. Okay? So these are the two facts I'm going to illustrate to you. Okay? Let's see exactly what's going to happen over here. So after this, what I'm going to do is I'll go to the Eclipse. I'm just going to type something here over here. I'll make the source code available to you today. So what I would do is, first of all, I would say system.out.println. Okay, I'll say local for C1. Okay, and then I'm going to say C1.L. Okay, just local. Similarly, I'm going to do another one here. Okay, let's do another line here. And then local for C2 over here, and then I'll say C2.L. Okay, and now how do we access the global? So there are three different ways there are two different ways you can access a global. Okay, let me show you all the ways first. You can say system.out.println global for C1. From C1's point of view, how should the global look like? I can say C1.g. Okay? However, this one over here, it's not very visible from the projector, but if you do this in Eclipse, it's going to give you some warning. Again, it's going to say G was declared to be static, so it should be accessed in a static way. It's not a compilation error, it's just a warning. Okay, that's why you can also write this, but it's not conceptually perfect. Okay, let me just write another line here. Go global for C2. Okay, I'm going to just change the context objects. This will similarly give you another warning. So these two lines will give you warnings. It's not really error. Okay, so now what would be the correct way or static way to access the G? This is how you simply use the class name, okay, before the dot. System.out.println. Okay, we're basically talking about the global value for counter, okay, the class. And now notice what's going to happen. Oh, let me make it larger. I can say counter, which is a class name. As soon as you say dot, it's going to give you option from the drop-down menu. Okay, when you try it on Eclipse, it's going to show you. You can say G. Okay, so now line number 17 should be the correct way to really access static variable. You simply use the class name dot the attribute name that is static. Okay, that's something new, I know. Okay, whenever we talk about context objects and etc., we always talk about non-static. We just introduce one extra thing, which is called static. The way you access static thing is by using the class name because they're global. Okay. So now let's try to see this. Now, to really avoid confusion, I would suggest I simply comment out these two lines. We only make it very simple, make it very clear. Whenever you want to get access to non-static variable, you simply use context objects. Whenever you want to make access to static variable, you use a class name. Okay, that's a very easy principle to remember. Okay, give me a few minutes and then I'll be done. Okay, so now let's see exactly what's going to happen here. If I say run, it's going to tell me local 0, 0, 0, also for global, right? That's exactly what we have. Oh, sorry, I forgot to re-put it. Because you can see that, sorry, let me just make it clear. If you see the counter over here, every time we simply just initialize the local to be 0. So that means in the beginning, we should have 0 for this copy here, 0 for this copy here. Okay, that should be no surprise to you. Similarly, you can see that in line number 9, we try to initialize the global static attribute to be 0, right? So that part there is just going to be 0. Okay, let's now do something very quickly. I just want to do two changes to you very quickly. So now let's see this. Okay, I only need about 2 minutes. First of all, if I say C1.increments, sorry, increment local. That's number one I'm going to do. Remember what increment local will do. If you go back to the counter class, increment local is going to say this.l. In this case, what's this? The context object C1. So it's going to be C1.L plus plus. Okay? So if I try to execute this line over here, if I say C1 the increment local, let's go to iPad here. When I say C1 dot increment local, is simply just going to increment this particular copy. That means C2.L will still be 0. And also counter.G will still be 0. That means we're only modifying this copy only this one here. Okay, let's make sure that, and then we'll do one final thing. Okay, after this, I'm just going to copy this line over here very quickly. Okay, I'm going to get, basically we're going to print out again C1.L, C2.L, and also the G, counter.G. If I do that over here, you can see after that, you can see it's actually 1, 0, and 0. Okay, so only one copy was changed. Let's do one more thing quickly. One more thing. So now, how do I actually increment a global variable? For example, if I say C1 dot increment global. Okay, let's have a look at what increment global will do. If you go there, increment global is just going to say G++. You can modify that. Conceptually, what's going to happen is, it's just going to modify this from 0 to 1. So now it should be visible to both C1 and C2. Agree? Okay, let's do that final check and then we're done. Let me go back to Eclipse over here. After this, well, what I would like to do is, after that, I'm just going to print this out and let's see what happened. Okay, if I try that, you can see that after this, you can see the global for the counter will just be 1. Okay, it's been modified. Okay, I will review this again from Wednesday and then I will continue with the programming pattern. Okay, see you on Wednesday.